Okay, now let's take this example to get a better understanding of the contour integral. We say find the contour integral of f of z dz, where the contour denote the line y is equal to x with parametric representation z is equal to x plus xi, where x is between 0 and 1, and f of z is equal to y minus x minus I into bracket 3x squared. Now here we have the range where x is. This one will stand for the limits of the integral. First of all, let us put the formula down. Now we say the contour integral over c of f of z dz is equal to the integral from a to b of f of z dt multiplied by the derivative of z dt, now dt. Now the z dt here, what does it stand for? The z dt here stands for the parametric equation given to you here. So you can see it here. The z dt is this one. So in the formula that I gave you before, this was the z dt I was talking about when we are dealing with a straight line. But here in our question here, it is given unto us already. So you don't need to go and find it. So because it is given unto us, so you have to go and use this one. So you can put down here that our z dt here is this. You can take your x to be t or anything. But here in our question here, we are dealing with x. So you can rewrite even this equation in terms of x here. So it will be the same thing as, let me cancel this one. It will be similar to the integral from here. We are dealing with the limit of integral 0 to 1. So we are having 0 to 1 of f of z dx multiplied by z prime dx. Now dx, we have to conform ourselves to the variables in the question here. So now the next thing is, what our z dx? Our z dx, as I said earlier on here, that is the parametric equation given to us. It is the xi plus, let's say x plus xi. So in the first place, you have to find the first derivative of this function. So we'll be having our z prime dx. So we are find the derivative of this function with respect to x. So here we'll be having 1, and for this one we'll be having I. So we have now our derivative here. Now we come back. When we look at this one, now we are coming to here, we say f of z dx. We have z dx here. So we are coming to replace the z dx here into our equation given to us here. And the equation is f of z, which is equal to y minus x minus I into bracket 3x squared. So now what we are coming to do is, like, we have to look at the relation that we are having here. Now what do we have here? We can see that our x here, let's take this one z dx. Our x here is equal to x, and our y here too is equal to x. So we are replacing the values of x and y in the equation here. So we'll be having now, because we know that here y is equivalent to x, so I replace it by x here. Now x is x, so minus the same x minus I into bracket 3. The x here too is the same as x here square. We'll be having this one. So by continuing, this is similar to, let's say, f of z dx. Good. So this one is going to give us here x minus x will give us 0 minus I 3x into bracket. Good. So now we have our f of z dx. So now we are free to go. So now our contour integral from 0 to 1 of f of z dz is going to give us the integral from 0 to 1 of, now look at the formula here. 0 to 1 of f of z dx, and now have f of z dx, you found it here to be equal to minus I 3x squared. So we'll be dealing with this one. So you replace it here, so we'll be having minus I into bracket 3x squared. Now we continue the formula. Here it is multiplied by the derivative here, and for that one we've already found it here. That is multiplied by 1 plus I. Now here dx. Now you have just a simple integration to do now. You just try to work it out. So this one is going to give us, now here, the first I here and 1 plus I, they'll be taken as constant. So they can come out. So we'll be having minus I 1 plus I integral from 0 to 1 of now 3x squared dx. Good. So now this one, if you continue, we integrate this one and you replace it by the limit of the integration here. So 3x squared, when you integrate it, to give us x to the power 3. So we'll be having minus I plus I. Now here we'll be having x cubed 0 to 1 here. And now here, if you replace it here, you'll be having 1 minus 0. That will give us the same 1. So now if you continue here, formerly we had, it was minus I into bracket 1 plus I. Now when we replace it here, you'll be having 1 to the power 3 minus 0 to the power 3 here. So it will be equal to, now here it will give us 1. So minus I 1 plus I. You can expand this. That will give us minus I here, minus I multiplied by I to give us minus 1, which is plus 1. You can better write it to 1 minus I. So this is the contour integral from 0 to 1 of f of z dz. So the solution here is 1 minus I. Thank you very much. I hope this video has helped you.